QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's consider this given quadratic equation. Is this factorable? Yes or no? The answer is no. Since this is not factorable, what should be the constant that will create a perfect square trinomial on the left-hand side? The constant should be positive 16. Then, what are the roots of this given quadratic equation? And the roots are positive 2 square root of 5 plus 4 and negative 2 square root of 5 plus 4. Did you get 3 over 3? If not, please continue viewing this video. Let's examine first if this is factorable. I mean, this trinomial, quadratic trinomial on your left-hand side is factorable or not. Because if this is factorable, we can proceed with the factoring in order for us to solve for the roots of the quadratic equation. But if it's not, we will proceed to the completing the square method. We know that A is equal to 1, B coefficient is negative 8, and C coefficient, or the constant, is negative 4. To determine whether this is factorable or not, let's use the AC way. AC is 1 times negative 4. The result is negative 4. By the way, we are doing AC way because we are sure that we cannot use extracting square roots here because we have the B coefficient, and we cannot use the common monomial factoring for C is around here, which is negative 4. Now we are going to examine the factors of this. We could have 1, negative 4. You could also have negative 1, positive 4. Then we have 2, negative 2, and negative 2 or 2, or they're just the same, so let me not write it again. So we have 3 sets of, or 3 pairs of coefficients that when multiplied will result to negative 4. Now, if we are going to add any of them, we could see that none of these results will be negative 8. Therefore, there can be no pair that can be used here to tell us that this is factorable. And in short, this is non-factorable, and hence we are going to use completing the square method. Again, this is again a method when we are sure that our trinomial is no longer factorable. In completing the square, we are going to make use of a perfect square trinomial, and with that, we are going to move out this C coefficient, as this will not make our trinomial perfect square. So we are going to move that on the other side, making it positive 4. And we are to add here a new constant. That new constant will allow us to come up with a perfect square trinomial, which could be factorable into a square of a binomial. Let us have C sub 1 to differentiate it with the previous C. The formula in getting the correct C in making a perfect square trinomial is in this form. The product of b over 2 and the square root of a, and then you square that result. Now, for some resources, they don't have square root of a because they consider a just like this, in our A are given as 1. But there are some instances under quadratic trinomial where A can be 4, 16, 9 other perfect square coefficients. So we are going to have it like this. So plug in all the values here. For our C coefficient, you will have negative 8. Don't worry about the negative. Divide by 2 times square root of 1, because we are going to take the square of it anyway. So we'll have the square of negative 4, and we will get the result of 16. So it's not negative 4, our original C, that can make our trinomial perfect square, but it's positive 16. So hence, we are going to add the same constant on both sides of the equation. So you have plus 16. And on the other side, you have 4 plus 16 as well. This is now a perfect square trinomial, which could be shortened into a square of a binomial. And by doing that, we are going to take the square root of the first term, x, the square root of the last term, 4, and the sign of the middle term, minus. Again, from a perfect square trinomial, you can have a square of a binomial with the first term as the square root of the first term of the trinomial. The second term is the square root of the last term of a trinomial, and the sign separating the two terms of a binomial is the sign of the middle term of your perfect square trinomial, which is equal to 20. That's 4 plus 16. From here, we can now further solve this as we take the root of both sides, or let me write it here. Again, we have the square of x minus 4 is equal to 20. Now, we take the root of both sides, take the root here as well, and we have plus minus here. So you will have x minus 4 is that's 4 is equal to plus minus square root of 20 can be reduced into 2 square root of 5. As to how, you might want to review your radical expressions. There are also separate videos in our channel that will help us in doing that. But of course, 20 is 4 times 5, and square root of 4 is 2. That's why 5 is retained as the radicand. But of course, don't forget the plus minus. And then add both sides by 4. You will have plus minus 2 square root of 5 plus 4. In short, our first root here, and again, we expect a radical expression since we use completing the square method, and our original given is not a perfect square trinomial. We have the positive 2 square root of 5 plus 4, and your x sub 2 is the negative 2 square root of 5 plus 4. These are the two roots of this given trinomial here. And again, this is made possible by 1, identifying whether this is a factorable or not. And since it's not, we proceed with completing the square, which will allow us to add a new constant which can make a perfect square trinomial. Don't forget to do the same thing on the other side to retain equality. Then from the perfect square trinomial, you have the square of a binomial, and since you have a square roots on both sides, and further here, considering the correct operations and the correct simplifying or the correct simplified form of the radical expression. So it's a little bit longer, but this is discussion for this QuadQuiz. Subscribe now.